Today's lesson, we're going to be talking about design layout. Specifically, in our objectives, we're going to introduce and identify the X and Y axis. We're going to plot out a piece of material. We're going to center a graphic on that material. And we're going to introduce the Z axis. And then lastly, we're going to talk about different machine applications with the XY axis. I've gone through the list of tech ed courses on the website, and these are the different ones that I have found to be relevant to this lesson. Now, some of them might be a little bit of a stretch, but I'm just going off of the names and descriptions that were provided on the website. The welding and casting processes, I threw that up there because you could use this when talking about the CNC plasma cutter when dealing with welding courses. So when we look at this, who can tell me where the X axis is and where the Y axis is? Which of these two is each one? Well, specifically, X is right and left, and Y is going to be forward and back, or up and down in this case. So we have the X and Y axis. Now, you may have seen this in math class. Maybe you have laid this out for plotting data and other things like that. Maybe you have some pieces that are plotted on there. And maybe you even graphed them and looked at some of the outliers and things like that. Well, how does this all relate to the design process? Well, if we start looking at some of our laying out of pieces and graphics, you'll see it comes into play a little bit better. A couple things we need to establish ahead of time is the different quadrants that we can work in. So this top upper quadrant is a positive quadrant. So any number that's plotted up here is going to be a positive and a positive number. The next one we have is a negative positive. So that means any number on the x-axis is going to be backwards from 0. And so those are going to be negative numbers, but anything plotted up would be positive. And we have the lower left quadrant here, which anything is going to be backwards or down, both in the negative direction. And we have the lower quadrant here, which might be positive from right to left and negative down. Okay, so our X is positive, our Y is negative. And this is the one that we're going to be focusing on today. So we're going to be looking at a machine called a laser engraver, and it will etch out graphics or things like that on a piece of material. And this is relevant to that XY coordinate because if we take a look here, we've got these two rails, and these two rails indicate our X and Y axis. And then up in the upper left-hand corner here is going to be our 0, 0, or our starting point. Now, when we take a look at that original graphic, that is where we're going to see that we're working, because our 0, 0 is here, and we're working in that same lower right quadrant, which is going to be X is positive and Y is negative. So we can lay over that quadrant if we wanted, right over our laser engraver, and see those specific fields. Now, our laser engraver does not necessarily have these denoted in negative numbers. It just says 6, but that's going to be positive 6 or positive 4. Okay, doesn't necessarily indicate like it would when you're laying out. Now, on the graphic side, when we're laying this out in our computer application, we have to lay this out accordingly, where we have positive to the right and negative down. If you try to plot something in a plus, it's going to be way up here on top rather than down below. So this is another application that you could see this XY coordinate used in. This is our CNC router. And our CNC router is down here in the lower left corner is our XY axis and our point of origin, or our starting point. So it's a little different. We'd be working in a different quadrant, and that quadrant would be the upper right one. So when we're laying out stuff for our CNC router, we're working in positive numbers, positive whatever, and positive X to get that laid out. And you can see there, if we superimpose that over there, that's where our XY would be. Okay, so your graph paper, you should have a piece of graph paper provided for you. And this graph paper, what I want you to do is think of it as the laser engraver bed. This whole paper represents the whole laser engraver field. So we could put a piece of wood up there, 16 inches by about 10 inches on our laser engraver. What I want you to do is we are going to take a piece of wood, and this piece of wood is going to be 8 inches wide, 6 inches tall. And we're going to plot this material out here on your workpiece. So I want you to take a pencil. You can draw some lines down if you want, but definitely put a dot where this should be. So when you plot this out, it's going to be right here. But what are these specific coordinates when we talk about this graph? Okay, if you've said 8, 6, that would not be right, because remember, we're working down from 0. So this would be 8, -6. Okay, and when we say that and we put that in terms of writing it out, this is an XY graph. So when we say it, we're saying XY. So this would indicate 8 would indicate that we're in the X, and Y -6 when we say it or write a coordinate like this. All right, so if we were to plot this as 8, +6, again, we would be way up on top of the screen and we would not be able to see that. So if you ever plot something when we're laying it out for the laser engraver and you thought you put a dot there or you put a line there, but it's not showing up, it's probably there. It's just probably in the wrong coordinate or the wrong sector from where you thought it was. And this again is representing a piece of material on the laser table. And so if we lay this out, okay, this box is going to be where I want to put my image versus the whole laser table that we see there. Okay, so this is that same spot. I've removed the wood grain, and we're going to plot blaze. So what I want you to do first is I want you to find the center point of our material. Now, that's just going to simply be taking those numbers in half. So 8 divided by 2 would get us 4. And so in the X, we're going to be at the 4. And in the Y, we're going to be 6 or -6 divided by 2 would be 3 or -3 here. So plot a point at X equals 4 and Y -3. This represents the center of our board and hopefully where the center of our graphic is going to end up. Now we're going to be plotting Blaze, as I mentioned, and for this particular application, he's going to be 3 inches wide and 2 inches tall. So 3 inches wide, how are we going to determine where he fits? You can see he's kind of an odd shape. He's kind of sitting at a little bit of an angle, and we want to be able to plot him just right. And if we put 3 and we come in and plot him, he's probably not going to have a center mark that is where it looks or is obvious to be. So the first thing we're going to do is we're going to look for the furthest point to the left. Okay, and we're going to do that by taking 3, and we're going to divide that by 2. So 3 divided by 2, that gives us 1.5. So 1.5 is the distance we're going to be off of our center mark for the furthest point left. So I'm going to take my center mark minus 1.5 inches, and that's going to give us 2.5. So I can plot that up here, and I'm going to start at my center. There's 1, another half, and 1.5. So at the 1.5 center minus 1.5, we should be at 2.5, and that's what we calculated. Okay. Now we're going to do the same thing for vertical Y, or for the right. We're going to plot out the right side of this box where Blaze is going to fit. So I'm going to do the same thing. I'm going to take 4, but this time I'm going to plus. 4 plus 1.5 inches should give us the coordinates of 5.5. So I'm going to go ahead and indicate 5.5 there on the screen for you as well. So you should have these two lines running at their correct markings, 2.5 and 5.5. Then what we're going to do is we're going to find the furthest bottom point. Okay, so we know that Blaze's head is 2 inches tall, and we're going to divide that by 2, and that's going to give us a number of 1. So now we're going to do that same thing we just did, but we're going to do it vertically, and we're going to use 1 instead. So what that's going to look like is we're going to take 3, -3, right? Because we're working down. So this is -3. subtracting 1, because that was the number we got. So -3 minus 1 is -4. So our bottom point of Blaze's head is going to be -4. So we're going to go ahead and plot or trace a little line there. Now what you're going to do is find the furthest point to the top, and that's going to be the same process. You're going to take -3 plus 1, that should be -2, and we're going to fill that in right up there. So now we have Blaze's head, and Blaze's head should fit into this box accordingly. Now, if you have the little freehand laser cut piece that I have handed out, then you don't know his orientation correctly. But what we're going to do is we're going to put him in there. And when we put him in there, we want the chin and the nose touching the lines, as well as the furthest back flame touching there and this flame up here. So that would get us his right orientation by having those points touching and then having our little parameter. Now we set these construction lines up, and we would actually take them out before we were to print this. Another thing you can notice is the center point of Blaze's head appears to be slightly to the left. There's more mass over here, more area over here, but really the distance over to the nose and the distance over to the furthest flame is the same distance away. All right, so we've plotted out Blaze on there. When we're done, we would have our piece of wood that has Blaze's head on there, and we would laser etch this just like this example you see here in person today. So when we go back and take a look at our XY axis, we see this green dot here in the middle. Does anybody know what that green dot would represent? It probably would be listed that most people would say it's a starting point or a point of origin, which is correct. But is there anything else that could represent besides the point of origin or our starting point? Well, if we take this and rotate it over a little bit and kind of put it in an isometric view so that we're looking at it from the side, this dot would represent our z-axis. And on some of our machines, it may not ask specifically for an x and y or a z coordinate, but we would have something that looks like a box here where we would dial in our thickness of our material. So the material thickness that we're looking at today with Blaze's head is 1/4 inch thick. Now, the reason this is important is because machines like our laser engraver have a lens on them, and that focal point needs to be at a specific distance. Otherwise, that lens is going to be out of focus, and our lines that we're going to see cut in here are going to be blurry and distorted, or maybe even not be able to cut through or cut very deep because it's out of the wrong axis or focal point. And so the other machines like the CNC router also have the same issue, because if you have your z-axis set wrong or your thickness, then you may cut way too deep into the material. You may also not cut deep enough depending on what you have your parameters set at. So the things that we've covered today, we've identified different quadrants. We've determined whether they're positive or negative numbers in those quadrants. We've plotted out a piece of material. This provides us visual and spatial references, so we can visually see how things are laid out. We've determined the size of an image, and we centered that image on the material. We introduced and talked about the z-axis, and we've also talked about different uses where you might see this, such as on laser engravers, CNC routers, and even plasma cutters. Thanks for watching.